circuit containing the capacitor and inductor along with the DC source. तो मान लीजिए ये एक सर्किट है जिसमें एक वोल्टेज सोर्स है V is a voltage source and there are 3 points 1, 2, 3. These are the two-way switch. इसको कहते हैं two-way key or switch. तो इस सर्किट में जब पॉइंट 3 को 1 से कनेक्ट करते हैं तो ये V सोर्स जो होगा DC सोर्स वो सर्किट में आ जाता है और करंट फ्लो होता है फ्रॉम C to R and then point 3, 1 and this voltage. तो कैपेसिटर का जो प्लेट है वो एक प्लेट पॉजिटिवली चार्ज्ड हो जाता है और दूसरा प्लेट निगेटिवली चार्ज्ड हो जाता है ये, और फिर रेजिस्टेंस का दिस प्लस पॉइंट and here it is minus point and it is the current flowing in the circuit. इस सर्किट की एनालिसिस करना है तो कंसीडर a circuit having a capacitor C in series with a resistance R and suppose that a DC voltage is applied. DC voltage is applied to it by connecting points 1, 2, 3 है ना, 1, 2, 3 कनेक्ट करने से as soon as voltage is applied, a charging current is flowing through the circuit and the capacitor starts getting charged है ना, इसमें that is storing of electrical energy, So after time t, let the charge on capacitor plates be Qt and the potential difference between them be Vc of t, as Vc of t is 1 by C into Q of t, and this is equation 1, and this is charging. This is charging of a capacitor C. Applying Kirchhoff Voltage Law, we have Vc of T plus VR minus V is equal to 0. This is equation 2. मतलब ये देखिए ये पॉजिटिव पॉइंट है. This is the positive point which create the VC. This is the positive point, that is VR, and here it is connected with the minus of source voltage. तो इस तरह से एक किरचॉफ वोल्टेज लॉ का एक इक्वेशन ड्रॉ हो गया. इसके वैल्यूज को यदि सब्स्टिट्यूट कर दें, दैट इज V T plus I T R minus V is equal to 0. So what is VT? That is QT by C plus I is dQ by dt into R minus V is equal to 0. R dQ by dt into R is equal to V minus this is QT upon C. This is V minus QT upon C. So we have this dQ by dt is equal to VC minus QT upon RC. This is VT minus QT upon RC. This is equation number 3. Now, separable of variables. Separable of variables जो हम यूज करते हैं डिफरेंशियल इक्वेशन में, तो उसके वजह से ये हो गया dq by vc minus dt is equal to dt over rc. dt over rc. Integrating, this is equation number 4. Integrating above equation, that is here it is dq by vc, this is equal to dt over rc. So if we integrate, then we find here it is minus log vc minus qt is equal to T upon RC plus A. A is known as constant of integration. Constant of integration. अब ये कांस्टेंट ऑफ इंटीग्रेशन की वैल्यू को हम फाइंड आउट कर सकते हैं. कैसे? When t is equal to 0, qt is equal to 0. Qt is equal to 0. So from the equation minus log Vc minus 0 is equal to 0 plus A. So A is equal to minus log Vc. Substituting this, we have minus log Vc minus Q is equal to T upon RC minus log Vc. So transfer कर दें इस पार्ट को इधर और इस पार्ट को उधर, तो माइनस this is RC is equal to log Vc minus Q minus log Vc. So this is minus RC is equal to log of this Vc minus Q upon Vc. And all these are log base E. These are log base E. Log base E can also be expressed as ln. It is also expressed as ln. तो ये हो जाएगा log base E is, this is Vc, that is 1 minus Q upon Vc is equal to minus T of RC, or anti-log of both sides. एंटी-लॉग होने पे क्या होगा, 1 minus Q by VC is equal to e raised to the power T upon RC. So this can be written as 1 minus Q upon VC is equal to minus T upon RC, or this is Q upon VC is equal to 1 minus e raised to the power RC. So Q is equal to VC 1 minus e raised to the power T upon RC. And this is, if you write as QT, then this is Q0 1 minus e raised to the power T upon RC. And this is the equation number 5. This is the equation number 5. And this equation is actual equation. This equation is actual equation when you see from this equation, when T tends to infinity, Q tends to VC is equal to Q0. So Q is equal to Q0 1 minus e raised to the power minus infinity upon RC. So minus infinity upon RC means Q0 1 minus 0. And that is Q is equal to Q0. So this point is Q0. Now dimension. Dimension of RC. Dimension of RC is, this R is ohm and C is farad. So this is ohm and farad is coulomb upon volt. So this is coulomb upon ampere. That is coulomb upon coulomb second. So this is second. This is second because coulombs cancel over here. So the dimension, thus the dimension of RC is the dimension of time and termed as time constant. Termed as time constant and denoted Greek tau. Tau is Greek language letter. Greek letter is tau. So the equation 5 कैसे लिख सकते हैं? This is QT is equal to Q0 1 minus e raised to the power minus T upon tau. This is equation number 6. Equation number 6. So the equations are Qt is equal to Q01 minus e raised to the power minus t upon tau, and Vt is equal to V0 1 minus e raised to the power t upon tau. So these are the equation 6. The transient current I of t is rate of change of transient charge Qt, that is I of t is equal to dq by dt. So this is d of dt. This is Q0 e raised to the power. This is 1 minus e raised to t upon tau. That is Q0 minus e raised to the power t upon tau minus tau. So this is minus, here it is minus plus Q0 by tau e raised to the power minus t upon tau. So this is Q0 upon Vc e raised to the power t upon tau. This is Rc, not Vc. This is Rc. So Q upon C is V, that is V0 by R e raised to the power t upon tau. V0 R is I0 e raised to the power t upon tau, that is IT. This is equation number 7. So this one is the equation number 7, that is transient current and transient voltage. So now we can have the time constant. For time constant, that is when t is equal to tau, then Qt is equal to Q0 1 minus e raised to the power minus tau upon tau, that is Q0 1 minus e raised to the power minus 1, that is Q0 1 minus 1 upon e, and that is Q0 e minus 1 upon e, that is Q0 e की value 2.71 minus 1 upon 2.71, and this value is nothing but it is Q0.632. So this is 0.632 Q0 or 63.2% Q0. This is a Q of t when t is tau. Similarly, the Vt is V0 e raised to the power 1, V0 1 minus e raised to the power tau by tau, that is 0.632 V0, and that is 63.2% of V0, that is Vt. And It is equal to I0 e raised to the power tau by tau, that is I0 e raised to the power minus 1, that is I0 by e, that is I0 by 2.71. So this is 0.368 I0, and that is 36.8%. 8% of I0 is I of t. So we have what we have. We have the expression that is this Qt is of this one type. This is Vt is of the type 0.6 and IT is 36.8%. This is 36.8%. We can plot the graph regarding this one is graphs. First graph is charging, then voltage, and then current. We have to draw the graphs of three components. So first is, this is time. So here the value is, say this is Qt and this value is Q0. So this is the curve. This is the curve for the current. This is the curve for the charge. This point is 0.632. 0.632 of Q0. Similarly, we have the voltage. This is time. Here it is voltage time. And this value is here. So this is the voltage. And here it is tau time constant. And that is 0.632 V0. And similarly, here it is the current. This is IT with time. So this value is something like this. This is I0. And this value is 0.368 I0. So this value is for one time constant. Now, if we increase the time constant, something like this. So this is tau large. Why it is large? Because this value is tau, which is greater than the black value. Similarly, this one is this is again tau, and this tau is more. Here it is time. And here in this case, this is tau is greater than this tau. So the variation of current, that is the time constant, when it is time constant is the required time to achieve 63.2% of peak value of charge or voltage V0 or 36.8% of I0 current. I0 is current. So the charging concept is discussed in this way. We can discuss the discharging of CR circuit. Discharging of CR circuit is something like कैपेसिटर, ये मान लीजिए कैपेसिटर है और ये एक रेजिस्टेंस है। सर्किट जो हमारा पास पहले से है उसी को लेते हैं कि ये 3 पॉइंट है 1 2 3। जब पॉइंट 3 को 2 से कनेक्ट करते हैं तो ये है C, ये है R। तो C के ऊपर क्या है? दिस इज द वोल्टेज, चार्ज पॉजिटिव। तो C जो होगा वो इस तरह से डिस्चार्ज होगा थ्रू दिस वे, है ना, इस तरह से डिस्चार्ज होगा ये। दिस इज द IT। तो क्या लिखेंगे इसमें? when the two ways key is turned to 2 in the circuit, that is 3 to 2 in place of 1 as it were charging, the circuit has acquired its steady state and current start flowing through the circuit as VCT minus IR is equal to 0 and I is equal to minus dq by dt, because the current decrease with the increase of the current decreases with increase of time. So the equation is, this is the equation 1, here it is equation 2. So VCT is equal to IR. So VC is dq by, this is dq by C is equal to minus dq by dt into R. So this can be written as dq by q is equal to minus t upon dt upon RC. dq by dt, that is RC. We have, this is separable of variable. This is separable of variable. Now we have to integrate it, है ना? इसको integrate किया जाए by integrating the above equation, that is dq by q is equal to minus TRC. So this is log base EQ is equal to minus, this is T upon RC plus A dash is constant of integration. Constant of integration. So when T is equal to 0, Q tends to Q0, that is log base E Q0 is equal to minus 0 by RC plus A dash. So this A dash is equal to log E Q0. So from equation, this is equation number 4, 5. From equation 5, we have what? Log E base Q is equal to minus T upon RC plus log base E Q0. So this is log base E Q upon Q0 is equal to minus T upon RC. So Q is equal to Q0 e raised to the power minus T upon RC. T upon RC. So this is equation number 6. This is equation number 6. From equation 6, we have the current and voltage. So voltage, that is Q by C, that is Q0 by C e raised to the power T over RC, and IT is equal to dQ by dt, that is Q0 e raised to the power T upon RC minus 1 upon RC. That is Q0 by RC e raised to the power T over RC. So this is minus, this is Q0 by, that is V of V0 by this e raised to the power T RC, that is minus I0 e raised to the power minus T upon RC, that is I of T. I of T. So this I of T is equal to minus I0 e raised to the power T upon RC. This is T upon RC. So from graphs, if we try to have this graph, the first is charging, that is discharging. Discharging is something, this is your time. Here it is QT and this value is Q0. So this is something like this. Second is voltage, VT. This is time and this is VT. So this is V0. And third, current. This is I0. This is I of T. Now, for the different values, different value means if we calculate the time constant, then for this time constant, we can have something like this, 0.368 Q0 . 0.368 V0 0.368 I0. These are the various time constants and its value for the discharging. Now we can have the 3-component circuit, and the simplest one is discharging of a capacitor through inductive resistance. Inductive resistance. So circuit is something like this is the inductive, and here it is the resistance. This is L and this is R. It is inductive resistance of a capacitor. This is C. And this capacitor is fully charged. We can take this is the fully charged capacitor. And this is close to the circuit, something like this. So this across voltage VL, VR and VC. VR, VL, VC. Current is flowing through this. This is your IT, current flow. So the capacitor has initially charged as Q0, which is acting as a source potential, acting as a source potential in the circuit, and would send a transient current, IT through the circuit. The current results in the voltage drop across the inductor as well as resistance. So applying Kirchhoff Voltage Law, we have minus VL minus VR plus VC is equal to 0. That is minus L di by dt minus IR plus VC is equal to 0. Since the current is decreasing, with time, then I is minus dq by dt and di by dt is equal to minus d2q by dt square. So this is minus L minus d2q by dt square minus dq by dt R plus VC is equal to 0. So this 2 minus makes positive, to L d2q by dt square plus this minus R dq upon dt plus q by c plus q by c is equal to 0, and this is d2q by dt square plus r by 2l dq by dt plus q by lc is equal to 0. And this one is very interesting, and it is second order differential equation. R d2q by dt square plus 2b dq by dt plus omega square q is equal to 0. This is equal to 0 is this is second order differential equation. Second order differential equation, and suggesting this one is so so this is second order differential equation, and suggesting the solution, that is qt is equal to a e raised to the power mt. One thing is important, that is 2b is equal to r by l and omega square is equal to 1 by lc, as it is. So this is solution. Qt is equal to a e raised to the power mt. So the first differential of this dq by dt is equal to a m e raised to the power mt, and the second differential, that is q double dot of t, is a m square e raised to the power mt. और सेकेंड ऑर्डर डिफरेंशियल इक्वेशन के जो हमारे पास सॉल्यूशन से मेथोडोलॉजी है, वो वही है जो हम पहले से यूज करते चले आ रहे हैं और डैम्प्ड ऑसिलेशन के केस में. तो हम क्या करते हैं, इनको डिफरेंशिएट करके इसको वैल्यू सब्स्टिट्यूट करते हैं. सो सब्स्टिट्यूटिंग these values in equation 3, we have equation 3 में जो वैल्यू सब्स्टिट्यूट करते हैं तो ये हो जाएगा a m square e raised to the power mt plus 2b a m e mt plus omega square a e mt is equal to 0. तो यहाँ पर a m e raised to the power mt कॉमन है. So we take a e raised to the power mt from the expression. तो ये होगा m square plus 2bm plus omega square is equal to 0. Now these are two terms, a e mt into this whole thing is equal to 0. So this implies ए ई रेज टू द पावर mt इज नॉट इक्वल टू 0। क्यों? क्योंकि हमने सजेस्ट किया है यही qt के बराबर। तो रिमेनिंग पार्ट इज 0 और वी कैन से m स्क्वायर 2bm प्लस ओमेगा स्क्वायर इज इक्वल टू 0। और ये क्या है? दिस इज क्वाड्रेटिक इक्वेशन, क्वाड्रेटिक इक्वेशन इन m के अंदर क्वाड्रेटिक। तो 2 रूट्स हो जाएगा, m इज इक्वल टू माइनस बी प्लस माइनस बी स्क्वायर माइनस ओमेगा स्क्वायर। ये 2 इक्वेशंस इसके हो जाएंगे। तो दिस वन इज इक्वेशन नंबर 5। तो इस इक्वेशन नंबर 5 के 2 रूट के वजह से जो सॉल्यूशन होगा इक्वेशन नंबर 4। सो इक्वेशन 4 can be written as, जैसे डैम्ड ऑसिलेशन का केस किया था एग्जैक्टली उसी तरह से हो जाएगा। अब इक्वेशन 4 हो जाएगा qt इज इक्वल टू a1 e रेज टू द पावर माइनस b प्लस अंडर रूट b स्क्वायर माइनस ओमेगा स्क्वायर होल ऑफ दिस t प्लस a2 e रेज टू द पावर माइनस b square minus omega square, and this is t. Now putting simplify करने के लिए p is equal to अंडर रूट b स्क्वायर माइनस ओमेगा स्क्वायर, ये हम यदि पुट कर दें तो क्या हो जाएगा? दिस qt is equal to a1 e raised to the power minus b plus p of t, and a2 is e raised to the power minus b plus minus p of t. अब ये जो इक्वेशन हो गया दैट इज 7th इक्वेशन। दिस इक्वेशन इज द सिंपलेस्ट इक्वेशन। अब इस इक्वेशन को a1 a2 कांस्टेंट्स है, इसकी वैल्यू निकालना हो तो बाउंड्री कंडीशन जो है, बाउंड्री कंडीशंस क्या है? बाउंड्री कंडीशन क्या? व्हेन t is equal to 0 तो q tends to q0 इनिशियली। तो दिस इज q0 is equal to a1 प्लस a2, a1 a2, क्योंकि e raised to the power is 0 तो e raised to the power 0 is 1, यहाँ पे भी 0 is 1। दूसरा है, इसको डिफरेंशिएट कर दें, dq by dt, dq by dt is equal to a1 minus b plus p e raised to the power minus b plus pt plus a2 minus b minus p e raised to the power minus b minus p of t। ये हो गया। इस इक्वेशन में डिफरेंशियल इक्वेशन ऑफ दिस दैट इज करंट IT से, IT में व्हेन t is equal to 0 current is equal to 0, so this 0 is equal to a1 minus b plus p plus a2 minus b minus p। इसको हम लिख सकते हैं द होल ब्रैकेट, इसको 2 भागों में ब्रेक कर दें तो ये हो जाएगा a1 plus a2, a1 plus a2 is minus b plus a1 minus a2p, है ना, ये p के साथ कोफिशिएंट। तो a1 plus a2 is q0, तो ये हो जाएगा 0 is equal to q0 minus b plus a1 minus a2 into p। इसको हम सॉल्व कर दें तो हमारे पास हो जाएगा दिस इज माइनस, तो q0b is equal to a1 minus a2 into p, और a1 minus a2 is equal to q0 b upon p, e upon p। और and we also have A1 plus A2 is equal to Q0, ये भी है पहले से। तो इन दोनों इक्वेशन से A1 A2 की वैल्यू निकाल लेंगे। यदि हम जोड़ दें, समिंग कर दें, दोनों इक्वेशन को समिंग कर दें, तो ये हो जाएगा 2A1 इज इक्वल टू Q0 B by P प्लस Q0। तो Q0 कॉमन निकाल दें तो ये हो जाएगा 1 प्लस B by P, जोड़ दें। अब सब्ट्रैक्टिंग करेंगे तो 2A2 इज इक्वल टू, ये प्लस है, 2 ये माइनस कर दें तो ये हो जाएगा दिस इज Q0 1 माइनस B by P, ये। तो A1 A2 की वैल्यू, तो सोल्यूशन क्या होगा? नाउ सोल्यूशन इज QT is equal to A1. A1 means Q0 by 2, 1 plus B by P e raised to the power minus B plus P of T plus A2. A2 means Q0 by 2, 1 minus B upon P e raised to the power minus B minus P of T. ये इक्वेशन हो गया एंड दिस इज इक्वेशन नंबर 8। ये एक जनरल इक्वेशन का सॉल्यूशन हो गया। अब इस इक्वेशन के सॉल्यूशन में यदि हम करंट का इक्वेशन देखें, इफ यू फाइंड आउट द इक्वेशन ऑफ करंट, तो क्या होगा? इट इज वेरी इंटरेस्टिंग कि इसको और थोड़ा सिंप्लीफाई कर दें तो ये हो जाए Q0 अपॉन 2P P plus B e raised to the power minus B plus PT plus Q0 by 2P P minus B e raised to the power minus B minus P of T. That is, this is, yes, QT, only QT. नाउ डिफरेंशिएट कर दें इसको। यदि IT लेना चाहते हैं तो क्या होगा? DQ by DT। IT लेना चाहते हैं तो ये होगा विथ माइनस साइन, तो ये माइनस, इसको डिफरेंशिएट करना है। Q0 by 2P, this is P plus B minus B plus P e raised to the power minus B minus P of T plus this is Q0 by 2P P minus B minus B minus P e raised to the power minus B minus P of T. Yeah. So this is minus Q0 by 2P and this is P square minus B square. P square minus B square. We have this kind of concept. P is equal to under root B square minus omega square. So P square is equal to B square minus omega square. So B square minus P square is equal to omega square. ये तो ये दोनों माइनस और प्लस मिल करके बना देंगे B स्क्वायर माइनस P स्क्वायर, तो ये हो जाएगा ओमेगा स्क्वायर e रेज़ टू द पावर माइनस B प्लस PT। और फिर यहां पर डिस्क्लोज्ड, यहां पे भी Q0 by 2P और ये माइनस ओमेगा स्क्वायर हो जाएगा। माइनस ओमेगा स्क्वायर क्यों? क्योंकि ये माइनस कॉमन ले लेते हैं, तो ये हो जाएगा P स्क्वायर माइनस B स्क्वायर, सो माइनस ओमेगा स्क्वायर एंड दिस इज e रेज़ टू द पावर माइनस B माइनस P of T। Here it is minus, it is already there is a one minus sign. So if we take this minus sign out, So this IT is equal to Q0 by 2P omega square e raised to the power minus B plus of T plus Q0 by 2P e raised to the power minus B of T with minus sign. With minus sign. So we have two expressions, one for charge, other for current. One for charge, other for current. And from this equation, take the case. There are three cases when B square is greater than omega square. So what is B square? B square means R by 2L whole square is greater than omega square means LC. So this implies R is greater than under root 4L by C. R is greater than 4 L by C. So this kind of reactive circuit, resistive circuit यदि होगा तो क्या हो जाएगा कि B square minus omega square is equal to P square. P square ये हम पहले से मान के चले हैं. तो इसके वजह से जो ग्राफ बनेगा, the graph is something as this is time, here it is current, charge. The first term is B plus P upon 2P, and this is something like dotted line. So this is Q0 by 2P B plus P e raised to the power minus B plus P into T. Yeah. This is the graph. E के power. And दूसरा ग्राफ बनेगा. This is minus B plus P upon 2P. And this graph is something like this. Second term. So it is curve 1, and here it is Q0 by 2P e raised to the power minus B minus P of T. Yeah. तो दोनों के रिजल्टेंट जो कर्व बनेगा, this is the resultant curve. This is the resultant curve. That is Q0 part से कर्व 1 and 2 दोनों कर्व के मिलाने से ये बढ़ रहा है, ये निगेटिव साइड में, तो शुरू में बढ़ेगा फिर ये घटेगा. तो ये ग्राफ, दिस इज ग्राफ फॉर चार्जिंग का हो गया. यदि करंट का हम ग्राफ बनाएं, if you like to graph this time IT करंट का, तो करंट में this is omega square, this whole factor, that is omega square by 2P. So this value is Q0 omega square by 2P, और ये जो ग्राफ है वो कुछ इस तरह का होगा. This is e raised to the power minus B plus T. और ये point, the graph is something that is minus B minus P of T. This value is Q0 omega square by 2P. Omega square by 2P. तो रिजल्टेंट ग्राफ जो होगा इन दोनों का सम, ये दिस इज ग्राफ 1 एंड हियर इट इज ग्राफ 2. तो दोनों का सम जो ग्राफ होगा वो इस तरह का ग्राफ. दिस इज द रिजल्टेंट. Here it is resultant 1 and 2 का जो सम ग्राफ होगा ये, मतलब क्या है, इट इज 0 पॉइंट, दिस इज योर 0 पॉइंट। तो 0 से ये बढ़ेगा, 0 से ये बढ़ेगा और बढ़ करके ये एक पर्टिकुलर पॉइंट कि पहले ये ग्रो कर रहा है करंट और फिर करंट जो है डीके करेगा, फिर करंट क्या होगा, ये डीके करंट। ये क्यों पहले ग्रो किया और फिर डीके किया, इसको हम निकाल सकते हैं, वी कैन कैलकुलेट। वी कैन कैलकुलेट, क्या कैलकुलेट कर सकते हैं, IT इज इक्वल टू ओमेगा स्क्वायर Q0 अपॉन 2P e raised to the power minus B plus P of T minus omega square upon 2B Q e raised to the power minus B minus P of T. Now differentiate कर दिया di by dt. So di by dt और उसको निकाल के 0 कर दे, तो ये हो जाएगा माइनस ओमेगा स्क्वायर बाई 2P Q0 minus B minus plus P e raised to the power minus B plus P T minus of minus B minus P e raised to the power minus B minus P of T. This part is common. ये पार्ट कॉमन होगा तो दिस इज 0, तो ये होगा माइनस B प्लस P e raised to the power minus B plus P of T minus B minus P e raised to the power minus B minus P of T. Yes, is equal to 0. This is equal to 0. तो एक्सपोनेंशियल का जो फैक्टर है उसको माइनस करेंगे तो ये दिस विल कन्वर्टेड इनटू द 0 1. तो दिस वैल्यू इज व्हाट वी हैव e raised to the power minus B plus P of T upon e raised to the power minus B minus P of T is equal to minus B minus P upon minus B plus P. ये फैक्टर है. एक्सपोनेंशियल को सॉल्व करेंगे तो माइनस बी कैंसिल हो जाएगा, तो e raised to the power 2pt e raised to the power 2pt is equal to minus b minus p upon minus b plus p और log एंटी लॉग लेंगे, एंटी लॉग लेंगे तो क्या होगा, 2pt is equal to log of e minus b minus p minus b plus p, and then this value t is equal to 1 upon 2p log e minus b minus p minus b plus p. ये है टाइम. तो इतने टाइम पर ये वैल्यू क्या होगा, पॉजिटिव होगा, माने करेंट फ्लो होगा. दिस इज द करेंट का नेचर जो हो रहा है वो ये नेचर में दिस वैल्यू इज टी एंड दैट इज ओवर हियर. तो डिस्चार्जिंग में करंट क्या है, पहले करंट बढ़ रहा है, फिर दिस इज मैक्सिमम और उसके बाद ये तेजी से 0 होगा, दिस डिकेज क्विकली. So this point is the case number 1 and it is known as deadbeat case. So case 1 is non-oscillatory or it is called deadbeat or heavily damped. कब क्या था इसका, b square is greater than p square. b square is greater than p square. What is case 2? When B square is approximately P square. So under root of B square minus P square can be considered is H, very small quantity. तो जो एक्सप्रेशंस आ रहे हैं सॉल्यूशन का, दैट इज QT. दिस QT इज इक्वल टू, जो QT हम लोग लिखते हैं, दिस इज Q0 बाई 2P माइनस B प्लस P e raised to the power minus B plus PT, and here it is Q0 by 2P minus B minus P e raised to the power minus B minus P of T. So we can consider the whole case as it is the taken common कि जो e raised to the power ht है, e raised to the power pt है, b square minus pt, ये बहुत छोटा केस होगा. The quantity is very small. Quantity very small में e raised to the power pt यदि हम बात करें तो this is 1 plus pt approximate, और and e raised to the power minus pt की बात करें for this purpose, then it is approximately 1 minus pt हो जाएगा, 1 minus pt हो जाएगा. तो simplified case is QT is equal to e raised to the power minus bt, कॉमन ले लिया, और A1 e raised to the power pt plus A2 e raised to the power minus pt, ये कॉमन. तो e raised to the power minus bt और A1 के साथ क्या हो जाएगा, दिस इज 1 plus pt, और A2 के साथ क्या होगा, 1 minus pt, 1 minus pt. तो ये e raised to the power vt, this is the 1, तो A1 plus A2 plus A1 minus ये pt, A1 minus A2 p of t, A1 minus A2 p of t. तो इसको हम कह सकते हैं, e raised to the power bt, A1 plus A2 is you can say A plus B T. So this is e raised to the power bt, A plus bt. This is QT, where A is equal to A1 plus A2 और B is equal to A1 minus A2 into P, ये इतने कांस्टेंट. तो इससे हमें फायदा क्या हुआ कि हमारे पास ये एक सिंप्लीफाइड इक्वेशन आ गया चार्ज का. और करंट के लिए करंट क्या होगा, I is equal to minus dq by dt, इसको डिफरेंशिएट कर दें. तो जब इसको हम डिफरेंशिएट करेंगे, दैट इज I of t is equal to minus e raised to the power minus bt into minus b a plus bt plus e raised to the power minus bt into b into b. तो जो एक्सप्रेशन हुआ, दिस इज माइनस ई रेज टू द पावर बीटी, कॉमन ले लें ये टर्म में, तो क्या हो जाएगा, दिस इज माइनस बी और ए प्लस बी टी, और यहां पे प्लस बी. तो इसको सॉल्व करें और सिंप्लीफाई करें, इसको सॉल्व करें और सिंप्लीफाई करें। तो बाय सॉल्विंग and simplifying, by solving and simplify, we can have Qt is equal to Q0 1 plus Kt e raised to the power minus Bt, or and It is equal to Q0 B square e raised to the power minus Bt, e raised to the power minus Bt. So rate of change में di over dt करें, di over dt में क्या होगा? This is Q0 b square e raised to the power bt into minus b. This is minus b. And if you put this is equal to 0, तो ग्राफ क्या बनेगा इसका? You see this one is Qt, this is Qt, and here it is the It. So this is something graph like this, T, and this graph is first here, and then this is something. So this value is discharging, continuous discharging. This is continuous decreasing charge की value. This is 0, 0 of time के रिस्पेक्ट में. करंट क्या है? करंट इस वैल्यू में इंक्रीजिंग और देन डिक्रीजिंग. This value is decreasing. And then this is the very important case, and it is termed as critically damped. This is critically damped circuit. When B is, B क्या मतलब क्या हुआ? B means R by 2L is equal to 1 by LC. So this cancel. This is R is equal to 2 by C. Circuit में ये condition है, then it is called as critically damped. Now comes to the third case, and that is important. The case number 3 is when B square is less than P square. That is under root of B square minus P square is equal to under root of minus 1, then P square minus B square. P square minus B square. And this, this is not P, B square minus omega square. B square is less than omega square. This omega square minus this. So this is minus of this into omega dash. So under root of B square minus omega square is equal to J omega dash, where J is equal to under root minus 1 imaginary quantity. This is imaginary quantity. So during this imaginary quantity, the expression of charge and current can be written as. चार्ज का एक्सप्रेशन क्या है? This is QT is equal to Q0 upon 2J dash omega dash B plus J omega dash e raised to the power minus B plus J omega dash T plus minus B minus and then plus J dash e raised to the power minus B minus J omega dash T. This. So we take the constant common, that is Q0 e raised to the power minus BT. Here it is minus BT and here it is minus BT. So we take common. So what we find this is 2J omega. If we multiply it inside the 2J omega, then we find B plus J dash omega upon 2J omega dash into e raised to the power J omega dash T plus minus B J omega dash 2J omega dash is this, and here it is e raised to the power minus J omega dash T. So Q0 e raised to the power BT, and inside the bracket, if you take this B common, then what we have? B upon omega dash, and e raised to the power J omega dash T minus e raised to the power minus J omega dash T divided by 2J. This bracket plus 2J omega dash, here minus, so this minus side, this will get plus so this value is e raised to the power J omega dash T plus e raised to the power minus J omega dash T upon 2, because this J is constant, cancelled, and this value is given as Q0 e raised to the power BT B by omega dash, and this factor is sine. This factor is sine omega dash T plus this factor is cos omega dash T, because e raised to the power J omega T is equal to cos omega dash T plus J sine omega dash T, and e raised to the power minus J omega dash T is equal to cos omega dash T minus J sine omega dash T. तो इसी को सिंप्लीफाई करके और सब्स्टिट्यूट कर दिया तो हमें ये हो जाएगा QT. दिस इज द QT. और इस एक्सप्रेशन को हम ट्रायंगुलर फॉर्म में लिख दें, दैट इज दिस इज Q ऑफ T इज इक्वल टू Q0 e raised to the power minus BT, and this is B upon omega dash cos sin omega dash T plus cos omega dash T. So if this part is sine, if this part is supposed to be, this is phi, and this phi is you can say B by omega dash, then tan phi is here, it is omega dash B. So we can have the value cos phi and sin phi as well. And from that cos phi and sin phi, we can express this is Q0 e raised to the power BT omega by omega dash sin omega dash T plus phi, omega dash T plus phi, because of the expression, phase expression. We can have it. Current I is equal to IT is equal to minus dq by dt. So this is minus Q0 e raised to the power BT omega upon omega dash minus B sin omega dash T plus phi plus omega dash cos omega dash T plus phi, and then simplify, you have this Q0 e raised to the power BT omega square by omega dash into sin omega dash T. This is IT. This is IT. So we find that here it is the change of phase phi in current as well as voltage. Means current and voltage both are not same. Means both the current IT and charge QT are not in phase. That is, there is some phase difference, and that phase difference is phi, that is tan inverse omega dash by B. This is the phase difference. Due to this phase difference, we can plot it. Graph. We have two graphs. One is the charge, other is current. First graph is charge. If we have this is 0, then this kind of the graph is there. This point is Q0 omega by omega dash square. So this factor is minus BT, and this factor is minus BT omega by omega dash Q0 minus this is omega dash, and here it is the resultant. Now, second one is current, that is IT. So for this current, we have this Q omega square by omega dash minus Q omega square by omega dash, and this is e raised to the power minus BT, here e raised to the power minus BT, and this is omega square by omega minus Q0, and this is multiplied with Q0 omega square by omega. And the current is, initially it is 0 and then increasing, and then it is decreasing, something like this. So see, this is IT. This is IT and this is QT. QT. This graph means current and voltage, charge. This is the charge oscillation in the damped oscillatory circuit, damped oscillatory discharge of a capacitor. Here it is current, oscillation in damped oscillatory discharge of a capacitor. तो जब कैपेसिटर के थ्रू, जब कैपेसिटर इंडक्टर और रेजिस्टेंस के थ्रू डिस्चार्ज होता है, तो इसमें 3 केस होता है, और 3 केस में ओवर डैम्प्ड, क्रिटिकली डैम्प्ड ऑन ऑसिलेटरी में द फेमस कंडीशन इज लॉगरिथमिक डिक्रीमेंट. This is logarithmic decrement, that is lambda. Logarithmic decrement में जैसे हम करंट का एक्सप्रेशन लें या डिफाइन करते हैं, इट इज द ratio of, it is the logarithm ratio of 2 successive amplitude in the oscillatory circuit. in the oscillatory circuit. So we take Q E1 is equal to Q0 omega by omega dash E raised sine omega dash t plus 5. Omega dash t plus 5. And this value is Q0 omega by omega dash sine phi at t is equal to 0. At t is equal to 0. So Q2 is equal to Q0 e raised to the power minus b t dash by 2, because we take the amplitude after two succession. This is A0, here it is A1, here it is A2. So this is minus bt by 2. Q3 is Q0 e raised to the power b of t, means 2t. And similarly, Qn is Q0 e raised to the power minus b n minus 1 t dash by 2. So ratio Q1 by Q2 is equal to Q2 by Q3 is equal to Qn minus 1 upon Qn, that is e raised to the power k t dash by 2. So this is nothing but it is lambda, e raised to the power lambda. So log is e n Qn minus 1 upon Qn is equal to lambda, e raised to the power lambda. So this lambda is equal to log e base Q1 by Q2 is equal to log natural log Q2 by Q3, and this is, and that is lambda is equal to b t dash by 2. What is b? b is r by 2l, r by 2l t dash. T dash is 2 pi. Under root of 1 by LC minus R square by 4L. R square by 4L square. Yes. So if we solve this, we are moving inside, then it is pi, this is cancelled. It is pi by under root of 4L upon CR square minus 1. LR is cancelled, CR is square 4, and this is, yes. So this is L, lambda, that is it is logarithmic decrement. So for a given circuit, we can calculate the logarithmic point and its circuit. So what we find? Finally, we find that summary of the case is case 1, when B square is greater than omega square, that is overdamped, and then R is resistance is greater than under root 4 L by C. Case 2, when B square is approximately omega square, so it is critically damped, and then R is under root of 4 L by C. And case 3, when B square is less than omega square, then it is oscillatory. So R is less than under root 4 L by C. Under root 4 L by C. तो इस तरीके से हम इसको डिस्कस करते हैं. और अब इसमें एक चीज और हो गया, जिसको हमने बहुत पहले कहा था कि चार्जिंग discharging of LCR circuit is similar to the damped and forced oscillation. And then thereafter, the same mathematics and technique will be used in case of galvanometer. The next topic is the galvanometer, और वो galvanometer हम लोग डिस्कस करेंगे. और उसके साथ ही जो 2 एक्सपेरिमेंट है, डेड बिट गैल्वनोमीटर, मतलब जो चार्ज सेंसिटिविटी है या करंट सेंसिटिविटी, वो दोनों उसमें डिस्कस किए जाएंगे. एंड दिस इज ऑल अबाउट द टुडे लेक्चर.